This is Layang Lintang team. My name is Muhammad Alif Jati, and I'm here with
Erlangga, Arya, Nadindra.
We are from SMA Taruna Bakti Bandung. We are currently taking part in ISTEMCC 2025 in Mechatronics 3 category. Our theme is Search and Rescue Vehicles for Astronaut Safety on Space. In this video, we will show you our prototype and how it works. As space exploration activities by agencies such as NASA and SpaceX increase, the need for emergency evacuation system is become more urgent. Exploring planets such as Mars and the Moon possess significant challenges, including the risk of accidents and the loss of assets, as well as limited medical access in extreme conditions. Therefore, there is a need for search and rescue vehicles that can respond to various emergency situations in space.
So we designed and built a search and rescue vehicle that is capable of conducting personnel rescue operation, retrieving critical assets, and providing emergency life support in lunar and Martian environment. With high mobility, load carrying capabilities, and life support system integration.
Our vehicles are vital for supporting the safety of space and exploration missions.
We designed our vehicle to be operated automatically, remotely, or manually by the crew members. Navigate extreme terrain using all-wheel drive and chain-wheel system, detect casualties or objects using radar and visual sensors, move obstacles such as debris using hydraulic alarms, and provide rescue space with life support system until the evacuation is complete. So here's the design we came up with. It's pretty complex and well made to fulfill our purpose. But unfortunately, we have to make a few adjustments for these competitions. We have been challenged to use 4D frames and are limited to using 4 DC motors and 2 servo motors. And we started at first, but eventually, however, we came up with the oversimplified prototype design that can still fulfill our purpose and follow the same exact principle.
In this prototype, we are using 2 servo motors, 4 DC motors, ESP32 motor driver, and 3 battery. And then we use Dable to control the robot, and here's the schematics.
And here's also the code we are using.
Now let's talk about the science and mathematics principles behind our prototypes. First, lower gravity reduces traction, braking, handling, and suspension loads. There's also Newton's laws applied, where the first law says that object stays at rest or constant movement unless X on. The second law says that greater mass means that more power needed to accelerate or decelerate. The third law says that tires push ground propels the vehicle. For the friction and mass distribution, tracks expand contact area for grip and uneven terrain. Low center of mass balance loads and improves stability. For drivetrain and steering, we use gear transmission for optimal torque speed. And we use 2 types of turning, which is pivot and differential.
So the second one is arm lift. The first ones we use force and torque, or the size of the motor or actuators are based on arm mass and acceleration. And the second one is hydraulics. We are using the Pascal principle and the static fluid principle.
For the energy system, we use solar panel to charge our lithium batteries. And then we realized that solar intensity in different planets is different, where Mars requires larger or higher efficiency panels, whereas the Moon allows direct high output collection. Here's the robot power consumption table that we make, and here's the battery info table.
So here's the battery info table,
and here's the runtime estimate for our prototype.
And so for our sensors, we are using a lot of things, but the camera, you can see the cameras. We have terrain scanning and mapping, navigation and localization, environment and safety monitoring, and last thing is victim detection. And the fifth one is rescue and cabin support room, or ECLSS. So the first thing it notes is cabin pressure, oxygen supply, CO2 removal, thermal control, and humidity and temperature sensors. And here's the demonstration of our product.
Ela chega e desencana com passo bem solto, passo bem solto, passo bem solto. Ela chega e desencana com passo bem solto, passo bem solto.
Designing the space SAR vehicle taught us the importance of taking a multidisciplinary approach to overcoming challenges in extreme environments such as Moon and Mars. Firsthand, we explored the integration of STEM to create an effective rescue vehicles. This experience reinforced our understanding of the need for robust adaptive SAR vehicles that can be operated automatically or manually in unpredictable terrain. We also realized through this activity how STEM theories can be translated into concrete solutions in a space context.
We hope that our design will contribute to the development of space rescue systems and can provide inspiration and material design for further development. And our goal is to create a design and build awareness for the importance of evacuation preparedness in space exploration. We hope that this project will encourage further innovation in space mechatronics and contribute to the long-term goals of creating safer, more sustainable and human exploration environment on other planets.